So it's this is, as I said, that this is very important. So hopefully you guys understood the logic behind it, why we have this kind of a supply function in the short run. And in a way, I kept my promise, right, to show you where does this supply curve comes from. But remember, this was the short run, right? So let's come back to our long run problem again. And then let's try to understand how we are going to figure out, because this is how we would get the short run supply curve, right? And then now let's try to get how we can get mathematically the long run supply curve of a firm, okay? So for that reason, we go back to the profit maximization problem, okay? Now, I'm going to, so let's keep this guy, but this was short run. Now we're going to be dealing with the long run. But let's actually have a look at this. So remember the profit maximization problem, it was what? Profit was equal to total revenue minus total cost, right? Suppose, let's actually try to figure out the same, for the same guy, which is a price-taking firm, let's say, okay? So this is going to be P times Q minus total cost, right? So we said that these guys are all functions of Q. But in the long run, what was total cost? Remember, what was it? So we remember the cost minimization problem. We figured all of these things out. So, right, so it's basically whatever you pay for to your workers minus whatever you pay for your physical capital, right? So this was your cost. And remember there, we said that, well, actually, when you decide on K, optimal K, and L, remember this what we said, you also decide implicitly on your Q, right? Remember our production function, it was f of Lk. So if you decide on L and K, you would also decide on your Q, right? So remember, in the cost minimization, we weren't deciding on Q, we were doing it for a given Q, right? So it was the minimum cost for a given Q. But then we learned how to decide on Q as well, right? From the profit maximization problem. Now, if I can write this like this, maximize profits, okay? And then this is going to be price times f of Lk. Let's put, instead of Q, I put this. Minus wage times L minus R times K, okay? And let me try to do this maximization with respect to L and K, okay? So this is basically, right, so we can also write this profit maximization problem like this. So is this for the short run or in the long run? This is for the long run, right? So this is where we're going to get the supply curve, okay? So then I would keep my promise. We would understand both the short run supply curve and the long run supply curve. And then in our next class, we're going to bring demand and supply together, okay, to determine the price in a market. So this is basically the case, fine. And then here, so this is, as we said, that in order to decide on Q, basically you can decide on L and K, right? So this is what we are going to do. So when we solve this problem, you're going to get, okay, you're going to get an L star, let's put it like this, and you're going to get a K star. First of all, when you solve this maximization problem with respect to L and K, is it going to be a constraint or an unconstrained maximization problem? Unconstrained, right? You told me, hocam, there is no subject to, right? There is no constraint here. So this is going to be an unconstrained optimization problem. Okay? And then, but when I solve this, now you guys know. These optimal levels would be functions of what? Remember, it was usually functions of parameters, right? So it's going to, what I always think of it like this. Okay, what is given here? What is given to me? They have to give me the wage rate, right? They have to give me R, and I'm a price taker. I take P as given, right? I could have written this also for, not for a price-taking firm, but still. Right, so these guys are given. So this guy would be a function of what? Of what? Wage, R, and no, Q0 was the case for the cost minimization. Now we're in the profit maximization. P, right? So you see, that's why these guys would be called, so this is also wage RP. That's why these guys, these are input demands, right? These would be called unconditional input demands, okay? Because they're not conditional on any Q level anymore, right? So these are called unconditional input demands. Okay? So let me remind you the cost minimization problem. So let's remember the cost minimization problem. Okay, so let's do this. Okay, so the cost minimization problem was this. So we were writing minimize total cost, which is wage times L, R times K, with respect to LK. So it was basically subject to, right, the amount that you would like to produce. So we were saying Q F of LK, right? So we were saying that you would like to have this equal to a certain level of output, right? Let's say Q0, right? So that's what we said. So when you solve this, so remember, this was cost minimization problem. So there comes the table that, that we keep using all the time, right? So you're going to see that there is this link between profit maximization and cost minimization. So this is the problem, right? This is the objective function. Again, so this is the objective function, right? So this is the objective function. This is actually the constraint. Okay, so that's what we said. And then remember, the solution to this was what? So when you solve the cost minimization problem, we got what? We got what we call the conditional input demands, right? And they were conditional on what? A quantity, right? So these here we call LC, KC, remember, and these guys were functions of what? I know you hate me for this, but I'm going to ask again. Okay, so this is wage R and Q, right? Or Q0. Wage R, Q0. These guys were called conditional input demands, right? And you see, apparently the ones that are coming from the profit maximization problem, they would be the unconditional ones because they're not conditional on a Q, right? So these are called conditional input demands. And remember, so this is what we were doing, right? So we had the objective function. Now we have the objective function. We have the constraint, right? Right, all these guys. And then we have the demands. So what was the value function here? What was the value function? Value function is what? You get these optimal guys, put them back into your objective function, right? Which is going to give you the minimal value, right? So that is your value function. So if you do that, what did we call our value function? Cost function, right? So it was called either TC or C. It was cost function, which was, I put these values back, wage times LC, wage R Q0, plus R times KC, wage R Q0, okay? Fine, so a cost function is a function of what? WR, right, input prices, and the quantity, right? So this was the value function, this is the cost function, okay? Or put total cost, whatever, okay? So here you're going to have a similar, so let me put this so that we would have our table here. Here I'm going to write down the profit maximization problem, okay? Now I have maximize, again with respect to LK, profit, which is P times Q, and instead of Q I write F of LK minus wage L minus RK, okay? Subject to what? None, right? So it was a tricky question. Okay, so this was basically, there's no constraint, right? So there's no constraint, nothing. or I don't know, just nothing, okay? So basically, and then when you solve this, as we said, you're going to get L star and K star, which are functions of wage RP this time, right? Because when you decide on L and K, Q is automatically, right, through the production function, Q is automatically determined. Wage RP, okay? And these guys, we call them unconditional input demands, okay? And then now, what is the value function here? This is new to us. Value function, okay? So value function is when you put these guys back into your objective function, right? So what is this? The value function. It would be, if we write this down, I'll write it here. We're going to call it a profit function, okay? Which is going to be a function of what? You guys tell me. P times F of L star, right? Wage RP, K star, wage RP, okay? Minus wage times L star, wage RP, minus R times K star, wage RP. This is the value function, and it's going to be a function of what? Wage R and P, right? Wage R and P. And this guy is called profit function. I know it's ugly here. I'm going to write it again, okay? So this is called profit function. Okay? Again, it's a value function. It's going to give you the maximum amount of profit, right? So given wage, R, and P, the market price, it's going to give you the maximum amount of profit. So this is what we call a value function. I'm going to write down the profit function here in a nicer form, okay? So profit function, okay? It is pi wage RP. This is going to be P times F of L star wage RP, K star wage RP, right? Minus wage times L star wage RP minus R times K star wage RP, okay? So this is the case. You see now we have another table. You see the relationship between these guys. So apparently here we have an objective function but no constraint. The demands that we get are called conditional input demands. The value function that we're going to get from here is the profit function, okay? Now, let's actually, you might tell me that, Hocam, I can solve this. I know how to solve this. So let's solve this guy, okay? And let's see what we will get, okay? So let me write it here. But still, I haven't told you where the long run supply is coming from. So just wait a bit. So we're almost there, okay? Before we need to introduce this profit function, okay? Now, let's actually solve this problem first. So let me solve this profit maximization problem. Maximize profit, P times Q, no Q, F of L, K, wage times L, R times K, L, K, okay? Now, if I want to do this maximization problem, what will I do? So we're going to take derivatives, right? So this is an easy maximization problem. We're going to solve, of course, given the fact that this guy is concave, okay, so that the maximum exists, of course. But then if I take, so this is basically del pi over del L, right? When I take the derivative, this is what? P times del F over del L, right? Minus what? Wage. This should be equal to 0. And then del pi del K, P times del F del K minus R should be equal to 0, okay? Now, what do these guys say? Again, we're not dividing them, but we are writing them, in a nicer form. Del F, del L, which is equal to wage, price times del F del K, which is equal to wage, right? So if I just take the ratio, R, if I take the ratio of these guys, right? So what happens? These P's cancel out, and I have what? Del F over del L, del F over del K, wage over R. What is this? Does this look familiar to you? What is this? This guy is, right, this one was called what? Marginal product of labor. This one was called marginal product of capital, right? And this guy is marginal rate of technical substitution. Do you remember this first order condition? Yes, right? Where was this? Where did we have that? In the cost minimization problem, right? So you see that again, there is this relation. Remember with the expenditure minimization and utility maximization, we also had this, the first order conditions were the same. And again, we have the same first order condition as the cost minimization, right? So apparently profit maximization implies cost minimization. This is what we say, right? So basically, so this is actually the case, right? So just keep this in your mind. Okay, now let's actually try to interpret this guy. What is this guy? Again, some grammar issues, okay? So let's actually, I can erase this because I have my table there. So now I'm going to ask you this. How can I interpret if I need to again explain it to my grandma, this first order condition? What does this mean? Wage equals to P times del F over del L. What is this? So let's think of it like this. If I hire one more unit of labor, right? How much money I will pay to this guy? How much will that cost? Yes?
Can you say again?
Yes. So we're trying to interpret this, okay? What is this? Okay, the first order condition. It's a mathematical condition, but we want to understand what's going on, okay? So if I hire an additional unit of labor, how much will this guy cost to me? Wage, right? So what do I pay to this guy? Wage. So if I hire an additional worker, this is going to be the cost, right? So let's put it like this, if you want, so that you would have nice notes. So let's say if you hire, because I don't like the fact that you keep talking, and don't write anything on the board. I never liked those kind of professors, so I try not to be one, but if I did, apologies. So basically, if you hire, so let me write this. If you hire an additional amount of, let's say, or unit of additional, so let's say unit is better, unit of labor, input, okay, contribution to your total cost, okay? So if I hire an additional amount of input, how would this contribute to my total cost? Wage, right? I have to, so contribution to my total cost. So what is this? If I hire that additional guy, how much will he contribute to my total revenue? So if I hire that additional guy, how much he's going to produce? How do we know? What is this? Marginal product of labor, right? So that additional guy unit will produce this much quantity, right? Let's say additional quantity, and each of these quantity I sell at what price? P, right? Again, it wasn't a tricky question, right? So let's say he contributes by 5 salads. Let's say at Mozart Cafe, he contributes by 5 salads. And each of these 5 salads, I can sell it at the price of P. So in a sense, if I hire one guy, he's going to produce this much extra output, and I can sell them at this price. This is going to be how much he would contribute to my total revenue, right? So additional unit will produce this much quantity, and you can sell those units of output at this price. Okay? So basically, this is going to be the total, the contribution of the input, right, to your total revenue. This guy has a special name, okay? It's called marginal revenue product, okay? So let me write this. Marginal revenue product, okay? Marginal MRPL. So this is basically marginal revenue times marginal product of labor. So what does this mean? If I hire an additional labor, he's going to produce this much extra, and each of those units I can actually sell it at, right, whatever marginal revenue it's going to bring to me. So basically it's something like this. Marginal revenue is this. Total revenue, let's put it del Q, okay? So this is an del Q, del L, okay? So marginal revenue product, basically it's del total revenue, del L. In order to reach this derivative, you have to, right, you go through basically the quantity, okay? So this is, you can write it like this. So this guy has a meaning. So it means that if I hire an additional unit of input, here labor, how much will that contribute to my total revenue? Okay? So in a sense, it's again, you're making sort of the additional, sort of the marginal revenue, you're setting it equal to the marginal cost. But this time, it's when you change the amount of labor. Instead of changing quantity, you change labor, therefore quantity changes, and because quantity changes, therefore your total revenue and your total cost changes, okay? So just keep this in your mind. This is important. Anladınız mı? Is this clear? So it's a concept, it's called the marginal revenue products, okay? So basically it means that, remember what was marginal revenue? Marginal revenue here, you had marginal revenue was del or D, let's put it, D total revenue, DQ, right? So this was here I had quantity. Here I have L. So that's why it's different, okay? It's the contribution of an additional input. Here, it's the contribution of an additional unit of output, okay? But because you use inputs to produce output, that's why when you want to use it in terms of inputs, this is how you write it, okay? So this is basically, so it's different from marginal revenue, okay? So this was marginal revenue, okay? So this is basically the case. Now, did you get this? Anladınız değil mi? Tamam. So it's, as I said, it's a concept. Now I'm going to keep my promise, okay? So you figured out that the first order condition is the same as the cost minimization condition. We learned about the profit function. Now, remember what did we have in the cost minimization? What did we have? So we used the envelope theorem. And how did we call this? Wage RQ0. What was this in the cost minimization? When you take the derivative of the cost function with respect to W, this was giving us what? In the expenditure minimization, when we take the derivative of the expenditure function with respect to PX, it was giving us what? Ne veriyordu? Compensated demand for X. So by the same logic here, when I take the derivative of the total cost with respect to wage, it should give me what? The right conditional input demand, right? So you guys know it. So don't be afraid, just say it, right? So this is the conditional input demand, right? And then basically, so we would have this, and then here, so and this was called what? Do you remember? The guy who found this, so let's praise the guy, right? So what was this called? this kind of, it was Shepard's lemma, right? So basically, but we said that it was an application of the envelope theorem, which is, you know, like a much more general result. So this is basically LC, KC, right? These total costs. So this is the case before, okay? So these were, we called it another way of Shepard's lemma. So, okay, similar to Shepard's lemma, right? Now I'm going to ask you the same question. And here, when I take the derivative of the total cost with respect to Q0, with respect to Q, let's put it Q here if you want, okay? So what was this? What is this? Bu neydi? Marginal cost, right? So nothing special about this. Okay, so now I'm going to ask you the same question for the profit function, okay? What do you think these guys are? Again, by similar logic and with an application of the envelope theorem, we have this. Del pi, okay, so suppose you have the profit function. Pi is a function of wage Rp. When I take the derivative of this guy, this is going to be what? No, with the same logic, this gives me the unconditional input demand, right? So this is going to give me L star wage Rp, right? Right? So this is, you see the logic, it's always the same. So you can apply the envelope theorem and then you can get the same result, okay? But do you think this is true? Remember the profit function. It looked like this. Wage Rp. So it was basically P times F of L star K star minus wage times L star minus R times K star. Before, in cost and expenditure, those guys were appearing with a positive sign. So what should I do? It should be like this, or there should be a minus in front, okay? So just be careful, okay? Because imagine, like, when you take the derivative with respect to wage, it's like, right? So it's going to be minus L star, okay? So del pi wage Rp, del R is going to give you minus K star wage Rp, okay? So these are results. Again, if I give you the profit function, you can just take the derivative with respect to wage and get these guys, okay? And now my promise. When you take this derivative of profit function with respect to what? Price, then you're going to get what? If you look at there, when you take the derivative with respect to price, you're going to get what? Q, right? So in a sense, with similar logic, this is going to wage Rp, and this is the long run supply function, okay? So this is how you get. So I kept my promise. This is long run supply curve. Now we have the short run one for the firm, and we have the long run. Apparently long run comes from the profit maximization problem, but which is written like this in terms of L and K, because you can change them both, right? And then when you find the profit function, you take its derivative with respect to P, and this guy is going to be your long run supply curve, okay? So I kept my promise. Now we know where supply curves are coming from, okay? So we know that they come from the profit maximization problem, definitely, but and how can we get the short run and the long run ones? Via this, okay? Now we have to stop here. I have to give you the evaluations, okay? So apparently tomorrow is the end, but for the people who are, no, not this course.